we've already talked about red and orange on the power side and green and yellow on the ground side. So now we're going to look at blue. Blue indicates communication between the sensor and the PCM. One is talking, the other one is listening. One is going to send a signal, and the other one is going to receive and read that signal. Now, when a device or a wire is sending a signal or a message through that wire, we color the wire blue to indicate that it is a communication signal. Now, TPS, for example, is a potentiometer. It sends the position of the throttle to the computer. It's mounted to the side of the throttle shaft, so as you rotate the throttle, that rotation is picked up by the potentiometer. It sends that signal to the computer. Now, it's always a 3-wire sensor. You have to have power, so the first one will be the 5-volt reference, the power side. You have to have a ground, so there'll be a reference ground. And then that leaves the 3rd wire to be the signal wire. Now notice again, this is not the color of the wires, this is the color of the circuit. In diagnostic purposes, we need to know the color of the circuit. So throttle position sensor, now this is not a wiring diagram, this is a component diagram. It's pretty basic, but it shows you how the component works. You'll always have a ground, so the ground is going to travel from the PCM out to the sensor. And if we were at idle, the ground would be down here. And you're going to have system voltage. System voltage comes into the computer. You see this resistor? That is going to change the voltage. So this is a dropping resistor. It resists down to 5 volts. So you're going to have a signal, power signal coming out here that is 5 volts that's going to travel to the sensor. So as you move from idle to wide open throttle, your resistance is going to change. That change in resistance is going to be reported through the signal wire back to the computer. Now let's see how this all works together in a diagram. Notice that you've got a vehicle control module. It's a dotted box, and you've got another one down here. Does that mean we have 2 vehicle control modules? No. Since it's a dotted box, remember that tells you it's only showing you what it needs to for this particular diagram. So we have 1 vehicle control module. Notice right here, these dots. They're connector 4, and over here we have connector 3. 16, 4. What does all this mean? Well, the C is the connector number. So this is connector into the PCM, connector 4, connector 3, connector 2. And the wire then, the number indicates the pin location in the connector. Now you know ECMs all can have various connectors, some 2, some 4. In this case you'd have pin or connector number 1, 2, 3, or 4. But if you counted across here, you would have 1, 2, 3, 4. So this would be connector 3, pin number 4. That's how it would be illustrated on the diagram. Now these pins can also be located in your service information manual. It's called a pin chart. It'll tell you what each pin is for, what wire it has. Usually it tells you the color of the wire. And you can find that in your service information. Oops, if you look close, I missed one down here. Just using this to show you how easy it is to miss things as you read diagrams if you don't look real close. Now in the middle you're going to see our components. We have the EGR valve, the MAP sensor, the fuel tank pressure sensor, and the TPS. Now these are the symbols that we're going to see in this diagram. You have a symbol for a coil, and if this is variable it would have an indicator like this, and you have a symbol for a resistance. And so like potentiometers, they can vary. So this is the symbol for a potentiometer or a variable resistor. Now if you notice the EGR over here, we have a coil. Now inside the EGR you also have a variable resistor or a potentiometer. The MAP has a potentiometer, and so does the fuel tank pressure sensor and the TPS. Those are both potentiometers. Now we have a 5-volt reference. That is our power source. It's coming from the PCM and going down to the sensors.
So what exactly is reference voltage? So if I wanted a 12-inch block of wood, I would come out 12 inches and make a mark, make a straight line, then I'd get my saw and cut it. So I should have a 12-inch block of wood. I've cut it at my 12-inch mark, but what do we have? As you can see, we've got a lot more than 12 inches. Now why is that? Because when I came out here and measured 12 inches, I had no reference point. 12 inches from here was just anywhere on the board. If I want actually a 12-inch board, I have to have a dedicated, specific reference point. What I should do then is fix one end at a permanent spot, then come out and measure my 12 inches. So if I wanted a 12-inch piece of wood, I would hook my ruler around a reference point, a fixed point, come out 12 inches and cut it, and I'd have a 12-inch piece of wood. Now in cars we don't use wood or inches, we use volts. So let's say this was 12 volts and I only wanted 5. I'd have to do the same thing, have a fixed reference point, come out 5, cut it, and that would be a 5-volt reference.
Question. Should the 5-volt reference be colored red or orange, and why? Remember the dotted box, and that means that you're not seeing everything in that box. You're only seeing what pertains to these components. Did you see a switch? If it is switched power, it would be colored orange. There's no switch in this diagram, but the PCM itself is switched on by the ignition switch, so it should be colored orange. It drops the voltage from system voltage down to 5 volts. Why? Why don't we use system voltage?
So why do we use specifically 5 volts instead of 12 volts? Now we're hooked up with our multimeter directly to the battery and nothing's on, and we have 12.5 volts. Now this is battery voltage. It is not system voltage. It supplies 12.5 to the car. Now I want you to watch that again. Watch the meter real close. Shut it off. Now you're going to see it drop below 12 and then go back up. Start it. Now we're going to raise the idle a little bit. Okay. So as you could see with this, 12 point something was the battery voltage. Once we start it, now it becomes system voltage because it's more than just the battery. Why? The alternator has kicked in and is boosting the voltage. But you see, when we actually went to start it, we dropped down as low as 10 point something, and then when we raised the idle, it went up to 14 point something. So there is no way we can use this as a fixed reference point. There's no way we can use battery voltage because batteries can age and the voltage can vary, and we can't use system voltage because it varies from starting the car, whether or not you're at idle, above idle. What if you turned on your air conditioning and the radio and the wipers? Your voltage would actually vary. So this would be like hooking your ruler around nowhere because it's not a fixed point. So why 5 volts? Well, a car will run off 12 volts. It would probably run off 11. It might start at 10, maybe even 9, but it would run bad if it started at all. But if you drop down below 6 volts, the car will not start. Therefore, they pick 5 volts as the reference point, the place to hook your ruler and measure from. So if we're going to calculate air fuel, we need a fixed reference point. So they pick 5 volts and everything is measured from 5 volts down to 0. Mass airflow, TPS, coolant temperature sensors, anything that is going to measure has to have a fixed reference point. Now some vehicles may use a 8 or even a 9 reference, but it would be identified in your wiring diagram. But for the most part, the reference point is 5 volts.
Next question. How do we get the 5 volts? Well, the PCM has an internal dropping resistor.
So of course the battery and the alternator give the system voltage, which is usually above 12 volts. That goes to the computer. The computer then, through a dropping resistor, drops that voltage down to 5 volts. That's the measurement point.
Here's an example of a dropping resistor in a simple battery circuit, but it'd be the same thing if this resistor was inside the PCM. It would limit the current down from the 12 volts to 5. Now at the top we have our 5 volt reference. Now since this is switched on, we color it orange, and those go down and they stop at the resistors. There's a splice here. Now notice that the EGR is not referenced to 5 volt. So since it doesn't reference 5 volts, it is system voltage. It's still switched on, so it's still orange. And we have to have ground. So we've got an EGR ground, a ground here that's going to come up to a splice and supply these 3. And then you have a ground over here that is going to supply the right side. 3 different grounds. So the EGR is going to energize this coil. The sensor ground for these 3 is going to come and splice off. And then the right side is going to go to the engine coolant temperature sensor and the TPS. Now we have some more grounds inside here. Now I've colored these yellow because they originate inside the PCM. So when the PCM turns these grounds on or enables them, then you can have a ground at each one of these points. Now notice there is a resistor in each one of these circuits. So it is a resisted ground. We really don't know how much, but it's not a full ground, it is resisted ground. Now if you know up the top of these, there's power on all sides, and there's ground at all sides to the potentiometers, power and ground, power and ground. But this ground that is switched on comes from the PCM. So this switched ground comes on and goes up here. Now as the TPS moves, as you step on the throttle, you're going to change the position of the TPS. That then is going to change this resisted value because you have power coming through, not as much resistance. Or if you let off the throttle, you'll have more resistance, and it's going to report that change down to the TPS sensor signal into the PCM. It's going to report a change in the resisted voltage. This voltage changes and it reports to the PCM. Now the fuel tank pressure sensor, the same way, as pressure builds or decreases, it's going to report it. So the blue wire is indicating a sensor. The map sensor, as more air comes in and map pressure increases and decreases, it's going to report it to the PCM. Now your EGR, notice that it had power and ground to a coil. So when that coil energizes, the EGR opens or closes. This resistance then says reporting how far it is open, because it can be open fully or just partially. So there's a coil, there is no sweep change here. The change comes from how far it is open or how far it is not open. And that reports that down to either open, closed, or partial. So when a wire is sending a signal or a message through that wire, we color it blue. So in diagnosing vehicles, you need to read the diagram. You'll have a power side, you'll have a ground side, and if there are sensors that are sending signals, they will have their own color as well. So in testing this diagram, you should have power at all the power inputs, and you should have ground at the ground inputs. And then as these sensors report, you should be able to go to that pin connection and see what the report is, be able to read it with your voltmeter.